Okay, so today this is going to be fun. We got real lucky that it's not raining. It's been raining pretty much all day, so hopefully it holds up. We're going to go through a few concepts and then I'll explain exactly what we're doing. You guys should have an idea what we're doing anyway because everybody read the lab for today. So perfect. Okay, so a couple of basic things. Number one, the atmosphere, and we talked about this a couple weeks ago too, the atmosphere is heated from the bottom up. So meaning from the surface goes up. So what happens? What does this represent? Shortwave radiation, right? So let's just write that down. Shortwave. Okay. And that shortwave radiation, that's solar radiation coming from the sun. It strikes different surfaces on the Earth and is re-radiated as long-wave radiation, right? Okay, and we talked a little bit about albedo a couple weeks ago, but I want to talk about that concept again. So I've represented in a really simple way an object or a surface with low albedo. That's this one that's colored all black. And then there's this one that's colored white. That's high albedo. So objects that have high albedo, do they absorb a lot? Not a lot relative to objects of lower albedo. So less. And I've expressed that as this thin line re-radiating less long-wave radiation than this thick line. So everybody gets that concept. So a surface that is, and that's a whole black car, white car thing, right? The white car is not absorbing as much radiation as a black car, right? Okay, great. So once you have that re-radiation at the surface, the air is then heated by convection. And that just means that the air is circulating, and whenever you have heat transfer in a gas, it's called convection. The ground is heated by conduction because it's a solid, right? So you have radiation going both ways, right? So it's re-radiating to the atmosphere. It's also re-radiating down into the soil. Okay, so that's a little basics on the heating. We'll review of that. So let's talk about adiabatic cooling. Can anybody tell me what adiabatic means? That's okay, I'll tell you. So adiabatic basically means there's no heat exchange involved. Okay, and that'll make sense in a second. So we know that when we go up in altitude in the Earth's atmosphere, what happens to pressure? Pressure decreases, right? And so that means that the air is expanding. And that alone, that process alone, without any extra heat exchange, that makes it cool. And if we remember the ideal gas law, pressure times volume equals nRT. T is temperature. So what happens if pressure goes down? What must happen to T?
Temperature goes down.
It also goes down, right? So that's this law in action. Air cools as it rises because it expands, or because the temperature goes down. Does that make sense? Great. Okay, and I've represented that here with this little diagram. This is the same parcel of air. There are 8 molecules there, and it's dense, and it expands. Temperature goes down. Okay, so we have this thing called a lapse rate. Now, lapse rate is a rate of change in temperature as altitude increases. Okay, so we also have this thing that we talked about a lot a couple weeks ago. It has to do with water and energy exchange. What am I thinking of? Latent heat. All right. So we have different lapse rates for a dry atmosphere and a different lapse rate for a saturated atmosphere. Okay. So, and I'm gonna walk you guys through this diagram because it's a little confusing. This is a lower rate than this. And the reason why it's confusing, obviously this is the steeper line when we look at this graph than this one. But this is because there's an interesting convention. Whenever we're dealing with height or altitude or depth or anything like that, we put that variable on the y-axis because it's intuitive. But temperature doesn't cause altitude change, right? And that's the other basic convention. We have the x variable or the independent variable on the x-axis, and on the y-axis we have the dependent variable. So usually this is the one causing this. It's not the case here, just a different convention because it's altitude. Does that make sense? It can be a little bit confusing. So actually this is the slower rate. I think I did this wrong. Did I make a mistake here?
Yeah.
It's backwards. Good. Those are the people who read. So we'll change that. Okay. 5.5 about. So today, it's kind of wet, right? It's been raining all day. So it's not raining right now, however. So where do you think we're going to lie on this spectrum?
Closer to the right.
Yeah, we should be closer to the wet, obviously. Okay, great. And we know why. We should know why this is a lower rate of temperature change, why the wet one is. Can anybody explain that to me?
Latent heat absorbs the energy.
It releases energy, right? So if there's more moisture in the air, and as we're going up, the air is expanding, which means it's also cooling, right? That means that the water in the air is condensing, and when water condenses, what happens?
Precipitation.
That can happen, but what happens in terms of energy? It's released. Yeah. So when water condenses, it's a phase change, right? From a gas to a liquid, it must release energy. That's latent heat exchange. Everybody solid, rock solid with that? Got it? Okay, so that is why when the atmosphere is very moist, that's why it doesn't change as much with elevation. Because as it's cooling, as the air is cooling and expanding as it goes up, water is also condensing into a liquid and it's releasing heat. It's releasing heat, which means the temperature is not going down as much. That makes sense? It's the same thing if you go to a wet climate from a dry climate. It's the same reason why temperature changes are such. Everybody got that?
Yeah. What is your job?
Air temp is like 11.5. Oops. You just broke up. And then surface temp is 6 degrees Celsius.
Did you guys get the
Elevation.
It sounds a little bit more effective than Snapchat.
Whoa. What? It's so different.
Probe temperature is 12.6 Celsius.
The air temperature.
The air temperature is, yeah.
12.6.
And then surface temperature.
Is this in the second column? Is this the second?
Oh, yeah.
Oh, wait, no, I think it's the second.
Surface temperature is 8 degrees Celsius.
So yeah, but you have to
Okay, you're right.
So the wet is 8. Remember that. And then the dry
relative humidity is 9.
Oh, yeah.
what was it, 8?
You get it wet.
Yeah. It was already wet actually.
What if? Because there is like, it's like,
Weird.
It's weird. Yeah, I know.
That makes sense though. That's why I was like,
Yeah.
Because we're actually lower here than we are over there.
Yeah.
like
What
we can tell
was
there's
the
kind
elevation
of
over
Optical
there?
illusion.
yeah.
3226.
Especially on the sides.
3226.
Right.
What do you call this?
Oh yeah. What did you put for vegetation? I guess.
Slight canopy mulch, maybe. Mulch deserts.
Oh, it's just odds, right? 1, 3, 7, 5, 6, 9.
Dry is so wet is 7. Dry is between 8 and 9.
Yeah, that's true.
8.5. 8.5. Okay, 7 and 8.5.
Still going like south.
It looks like 9. So 7 and 9.
Well, I think we're doing west aspect.
Oh.
West
We're
for,
using the mountain.
West for the mountain, yeah.
Definitely on the west coast.
So wet
Alright, yeah,
is
that makes sense. So west, and then for down here.
Just sticking with
so
west.
someone can remind me. So the wet is this top measurement, right? And then the dry is this middle one in action. So I think 7 and 7.
Make sure you guys do that over the concrete too.
So if I have wet was 7 and the dry was 9. Oh wait, this is the side.
There
This
you
is a
go.
smaller measurement.
Okay, yeah, I was what? So 7 and 9. I just match them up. So it's 6, 6, 7. Does that look right?
Yeah. And then you go with what that points to
On this top part.
on
no,
the
wait.
right down there, yeah. That's your
Ah.
percentage.
Oh. This part is the percentage?
I think so.
I don't think.
Oh
That's
yeah.
high.
Oh yeah, it's supposed to be
It's like-
that part where that's pointing.
Where the
to.
Y
Okay,
goes.
so was I
Yeah,
lost
so
one
I
now?
messed up on the
That's
last
okay.
one. Yeah.
Okay, so well, this one is 72. Yeah.
So, 34,
We're supposed to take,
You like grass
34, 30.
34, 30.
we're supposed to take 3 measurements with a laser, right?
Surface.
Yeah, surface measurements.
Obviously, like, vegetation, not the.
I think like maybe like vegetation, dirt, and then rock or something.
Yeah.
Bench.
Yeah, rough. The one we're really interested in you guys doing is the end.
Yeah.
45. This, yeah.
Is it in here? You can convert it to
Hopefully.
Celsius.
Oh!
Press. Yeah.
So much better. Okay. 7. Probe temperature or air temperature is 7.8 Celsius. And then what do I change that to Celsius?
You have to press that one. Kind of tricky.
Yeah, 4 Celsius.
4 degrees
First-
Celsius.
Yeah, first temperature.
And then, so you're gonna do dirt, grass,
Yeah, so that was like rocky dirt.
rocky dirt.
I'd do like a patch of grass. Patch of grass is 4 degrees Celsius also. How about like straight?
Yeah, that works.
And
74.
5 degrees Celsius.
Whoa.
5 degrees Celsius.
Changes. What was our relative humidity?
74.
74%.
And so,
I have it.
Sorry.
Whoops. Who wants to do it?
you want to do
That
this?
bad boy.
It's already pretty wet. I don't know.
No, we got 85. I messed it up. Soil was 7. Rock was 6. Grass was 8.
35, 45 for the elevation.
Right? GT.
Huh. There we go.
Okay. Do you want me to take?
Alright, we
So
got
for air temperature. Oh, sorry.
9 degrees Celsius, and then there's that little slot. There's a little slot. Right, 9 degrees Celsius and
Wait, isn't air temperature right there?
Oh yeah.
8 degrees Celsius. Or 7.
Is that 9 dry? Is that-
Which one's dry and which one's wet?
Are you guys recording?
That one's wet, then it was 7 wet, 9 dry.
The air temperature is 9.
9?
Gives us 69% humidity.
Alright, it's good enough. Now it's ready. Sling away.
So 8.5 for air temperature.
8.5 you said?
Yep.
You should be able to like sing a song. Not when the song's over, but it's time.
I think it only needs like 20 seconds.
Yeah.
You want to just
Thank you.
Elevation is 40, 60.
Yeah. 80%, 85% humidity.
And it was 74 at our last stop?
Might
Yeah.
be.
Wow.
I guess it's raining.
Yeah, it
Alright,
seems
sure.
like it just started
85.
raining.
Yeah.
Yeah.
That's a notable change.
I got 4 degrees. For grass, I got 5. And the M was 3 degrees. And the surface, or sorry, the air temperature is 5.2.
Ooh, this is some sort of
Snow, yeah.
scaly, sleety.
Cool. Okay. Well, the only other thing I want to say is that there are, 5, 6 questions to answer. So you're going to type up a written report. There's a few graphs involved. You're going to do some calculations with the data you took today. And everything's based on the concepts we spoke about down at the bottom. So if you didn't write down those all that stuff at the bottom, or didn't take a picture of it, we'll hang out until everybody goes through, and you can get that. There is also some data that I posted on Moodle that you're going to use in the last 2 questions, and it refers to that. So there's 3 different Excel spreadsheets of different temperatures and then relative humidity. Any questions? Okay, well we're going to come back next week and we'll meet in the same place. Hopefully it's not raining next week. We'll see. And we're going to hike higher next week. So